Okay, so here first thing I have to do is, see this here, I have to enter this sequence over here, x, right, divided by what I got, x to the power 7, right, plus how much, 50. Okay, am I good? Okay, so this is how my sequence is defined. So if I have to add 100 terms, what I do first is I go to math.
Second?
Yeah, math. I always forget which one will be.
Math.
I know it was not. I have to go to second. No, not even that. Probably second. Yeah. I have to go to second stat. Okay. Then
math.
no. So see this here. Go to math then. Okay. Here is my sum. Okay.
Sum.
There you go. Oops, sorry, I went to the wrong place. See, I should have gotten out of here first. Okay. So, well, it's good. Now I'll remember. I do this, right?
Math.
Then I go to math, right? I go to sum. Then I do the same thing again, right? Huh?
Same thing again?
Yeah, because I have to get some sequence, right?
Okay.
Now sequence is here in the ops, right? Makes sense? Now I will put y1 in here, right? How do I get my y1? I go to vars, right? Then I go to y vars. Then I have functions. I got y1, right?
Or we can write down 2 or no?
No, you can write it down, but this way, this way it's easier, you know, and you will avoid mistakes. And
Yeah.
I'm adding with respect to x, adding it from 1, right? Through how much? 100, right? So the answer is what? All that, right? Makes sense? Okay. Now for the other ones, the situation is now easy because see, we can always do this. Let me save it. So where were we? Right here. See, you can say second enter. So the whole thing comes back. All right.
Oh.
So I mean, just makes life easier. Nothing
Yeah,
more.
yeah. Lots of steps.
Right.
You miss one.
So now it wants us to go up to 200. So all I have to do is change.
200.
Okay. So when I do that, you know, the sum is that, right? What's that? It's almost the same.
Yeah.
Almost no change, right? Okay. So
Same number.
yeah.
Why? How it happened? How did
Yeah,
it-
because
yeah.
it's a convergent sequence, so it's converging just
Converging at that point. So.
right, pretty fast, isn't it, right? And let's see if we go further down. Then how many terms do they want now? 400 and 500. Let's give it 400 and 500. 400. Should still be the same. Come on. Yes, still be the same. Right? Makes sense? Okay. So you can write it down, right? Okay. So you have 1, right? Then 1, then add them together, 2, right? add them 3, right? Add them, you get 5, add, you get 8, add, you get 13, then add, you get 21, then add those two guys together, what do you get? 34. How many we got? One, two, three. We just need one more, 55, right? Makes sense? See, 1, 1, then 1 as it said, and then the next term is 1 plus 2, that is 3 plus 3, right?
13, 14,
Right.
21, 22,
Right. Now you have to write who? A n plus 1 over a sub who? N, right? So who they will be? 1 over 1 is 1 right here, right? 2 over 1 is 2. 3 over 2 is 1.5, right? See that here? And 5 over 3 is like 1.67, right?
So we are doing 1 by 1, 2 by 1, 3 by 2, 5 by 3,
Right.
8
So
by 5.
yeah, 8 over 5 would be 1.6, right? Then 13 over 8 will be 1.6, no, 6, then 2 approximately, right? Okay, all right. See, 1.6, what was that? Okay, yeah, 1.62. Then 21 over 13 would be?
1.62, something like that.
Right. So what is 21 over 13? 1. 6 again, right? 6. 1, right? So here we will write 21 over 13. There we go. Yes, actually 6, 2, right? Okay, let's check our earlier one also. I am tired today, so.
It's okay. I will just little bit, then I will go.
No, don't worry. No, I'm just saying, I just want, yeah, here I thought that, yeah, we can make it 1.63, right? Okay, very good. No, don't worry about it. Okay, and then what we got? 34 over 21. Okay, 34 over 1.62 again, right?
It stops at 1.62.
Close to 55 over 34 is yeah, 1.62 again. And actually a better way to do that will be, we had seen that before via Excel, like say this. See this here? Let me enlarge it.
I never use the Excel like that.
Yeah, right, whether you can. So see, 1, 1, right? Okay, then 1 plus 1 is 2, right? Okay, so here, so we add these together, right? Then here we do what? We add these guys together, right? Okay, then here we add, see that here? Okay, let me see if it, yeah, see, it's continuing like this, right? See this? Okay, I went too far. It's okay. Yeah. All right, so see, we got that, right? So here I could do this. Look here, Gopal. So now I could do this divided by that, and when I do this, see, 1.621. Okay, so I could see the the ratios coming up like this, right, in a spreadsheet. So anyway, going back, so we are done with that one, right? Okay, so let me put that up there in there for you. So where is it? Okay, so we got these guys and we got these guys right here for this, right? Okay, are we good on this? Okay, so let me just save it so that I can post it.
Yeah, please post.
Right, that's what I'm saying. Okay, just a second. So this is the test to previous answers, right? So I'll just say okay. So now let's look at the next question here, what that was. Okay. So we did this, right? Now then we have to get these guys, right? Okay, so first
So whatever you find the limit of the following sequence, so we
right,
we always have to assume that limit n tends to infinity.
and goes to infinity. In this case, yes, by default that's what you will assume. Yes, that's absolutely right. Okay, okay, so here you go. I'm just putting them here,
Yeah.
like separately, so that we can write these guys here. Okay, so then we got this, and then we got that here, right? So let's look at this one first. So in here I have square root of what? N is square, right? Plus n, right? And then what was the other thing? Minus n. Very nice. Divided by how much?
Nothing.
Nothing.
We have to, conjugate.
I see. Oh, very good. I'll do it that way. Okay, so when we got that, so I'll just take your suggestion.
No, do your way. So I will.
No, I mean, I'm just going to try your way. You are the one who has to take this exam, right? Okay, so here I'll just multiply and divide by conjugate. Okay, 1 sec. So this is how much? So we have n square, right?
And will be left over.
Right, and will be left over. Here we got this. So why don't you give me the limit, and I just have to put a sweater on because this is, I'm feeling a little cold. So let's see.
Sorry, if you're feeling not good.
No, I'm okay, I'm
you
okay.
later, no problem.
No, because see this cold air here. Now the building is set on cold. Okay.
Oh, already they said on cold?
Right, and you can see the duct is coming right on my head. That's why I have to keep it covered, otherwise, and then so
Outside is very hot.
and here it's very cold, but it's okay.
Almost
I mean,
equal.
if it's cold, I mean, I got this sweater, I'll put it on and I'll be fine. Okay, all right. So here we, yeah, here. So what's the value there then, Gopal? See.
One.
Actually, let's see, as it goes
We
to
have to take out n from here and from here.
there, so when you do that, see what happens? You get an n, right? And when you have, when you're taking an n out of
1 plus 1 by
say we are taking, yeah, right, n square out, right? So you have 1 plus 1 over n. Okay, and then that guy is outside plus 1. So what do you have actually? This equals this.
1 by 2.
Very nice. So see, there was a little, yeah, it's not 1 over 2. Beautiful. And you could see a table of values, or you could have gone ahead and graphed it, right? Okay, there's so many different ways that we could have done it, right? Okay, so here we are. So we are done with this guy here, right? Okay, and just a second, one moment, let me erase it so that, okay, good. So we have this one, right? Are we good on this? Then who is the next one? Let's go back. I keep looking. Okay, this is the one that we have to handle next. This one should be pretty easy. Just use this. How much is it? This is like show and tell, right? Yeah, what would you say?
3 by 5.
Very nice. It's 3 by 5, right? Yeah, very good. So we didn't have to do much here, right? Okay, so we'll just write it, right? Converges to 3 over 5, right? Okay, then let's go to the next one. So here, notice this, as n goes to infinity, 1 over n goes to 0, right? And cosine inverse of 0 is what? Pi over 2, right? So what you have is sine of,
Pi over 2.
so yeah, right. So sine of, it says cosine inverse, right? That's what it said. Of 1 over n, that goes to sine of pi over 2, right? Okay, because what? Yeah, right. Because the range of cosine inverse is what? 0 to pi, right? So that's how we and this equals what? 1. So that makes sense. So excuse me. Okay. All right. Makes sense. Good. So we will say this is page 2. So now let's look at this guy here. So here, so you had n times tangent of what? 1 over n, right? So this can be written as what? Tangent of
1 over n.
right? And if I wrote it like this, this is sine of 1 over n, right? Over 1 over n, right? Times cosine of 1 over n, and if you split it, you have 1 over n, right? And then we have 1 over n again, and then we got what? This times. Now as n goes to infinity, this quantity goes to 0, this quantity goes to 0. So sine theta over theta, as theta over goes to 0, goes to 1, and this will be cosine of 0, so that will go to 1, as well. So the whole thing will go to what? 1. Beautiful.
This when limit 1 n tending to infinity, that this become 1 sine 1 over n.
Yeah, because it just takes that format. Remember that that limit of limit.
Yeah, I remember.
Yeah, that's one of the exactly. That's one of the standard results.
Yeah, I got
That it's okay. I'm just say as theta goes
sine
to
theta upon theta equal to 1.
very good. Sine theta over theta equals 1. Right? Beautiful.
But if we plug in infinity here, it's not coming the 1 value.
Which one?
This is the standard rule. We all know that. But if we plug in n value and infinity here,
Right. So that
it's not coming up.
no, but it comes out because you'll take theta as 1 over n, right? Wouldn't you? So that becomes of the same. Then that comes out in the same form. Then sine theta over theta as theta goes to 0, right? Good. Very good. Okay. So there we go. We got these guys, right? Okay. D, there's no E in here, which is okay. Now this one, remember this? For
Log,
this,
take log,
very good. Just use L'Hopital, right? Okay. Use of ln and L'Hopital.
So we don't read it as L hospital.
Yeah, right, exactly. It's just pronounced as L'Hopital, and you can call it L hospital, nothing wrong with that. Okay, the limit as e to the negative 2/3. Okay, all right. Makes sense?
Yeah.
And then we will look at this. See, cosine n pi over n plus 1. Here I can apply the squeeze theorem, can't I? See? Let me show you. See this here? Now, if I have, say you have cosine of n pi, right, divided by n plus 1. That's what you got there, right? Cosine of n pi divided by n plus 1, right? So what happens here? See, cosine of a quantity always lives in between -1 and 1, right? So this guy will be bigger than negative, right? Very good. So over n plus 1, and will always be less than or equal to 1 over n plus 1. As n goes to infinity, what happens? Both the extremes go to 0, so the middle one will be squished to 0. Okay, so the thing is, so that goes to 0 by the squeeze theorem, right? So we have right? Good. So we are doing good, huh? Good. Okay, so let's see what they had further down in there. So now we have to do this. Okay, now you can of course see for this one you can of course use your calculator to find this value, but let's try to do it analytically. All right, am I making sense? So,
and please show me how to do with the calculator.
Sure. So see, it's 3/11 to the power n, and I'm ignoring the absolute value because this quantity is positive.
Yeah,
All right, so it doesn't really matter not to use this absolute is less than 0.001, right? Okay, so this is what I have to do. So what do? I take natural logs on both the sides. Okay, see this here? So here is, now natural log is an increasing function, so the direction of the inequality is respected, right? See that here? Okay, so now what happens is I can pull this n down, right? Okay, are we good here? Now I can divide by ln of 3/11, but ln of 3/11, that is going to be a negative quantity, right? Because that is a number less than 1, right? See this here? See, it's a negative quantity, right? Isn't it? Notice that? So when I divide by ln of 3/11, what will happen to the inequality sign? It will switch, right? You agree? Because when you multiply an inequality by a negative number, the sign switches, right? Because you can just say this, because this quantity is less than 0, right? You're with me, right?
I did get that. When ln3 we divide by ln311. So because of negative signs.
Right,
okay.
Exactly, because that's a negative.
It's confusing. You know that it's negative value. I don't know that unless.
No, now you know. You will always know now. If we just stumble on this once, and then we know it always.
Okay.
So this is how much? 5.31. That means, okay, must have, or rather, how many terms do you need? 6 or more, right? Okay, see this here, smallest positive.
How do you know 6 or more?
Yeah, because 5.31, my little n has to be greater than 5.32, right? Who is the smallest positive integer that's greater than 5.32? 6, okay?
So now, we cannot say 5.33.
Oh no, because it's integer, that's what it wanted, right? Okay, so let me just first put this analytical thing up here.
So answer is n equal to 6.
N equals 6. Now let me show you how you can do it in your calculator. Okay, so it's goes like this. See this here? I'll go ahead, erase it, and we got what? 3/11 to the power what? X, right? Okay, and then when you look at the table, when you look at the table, okay, then notice this.
The table already set.
Table was already set. So what did you want? You wanted it to be less than 0.001. So at 5 is less than 0.001501, right? Makes sense? It's slightly more than 0.001, isn't it, right? But at 6, what happens is, okay, it becomes smaller than what you wanted, right? Are we good on that? Okay, So that's how you will use your calculator to do that. But if the question asks to do it analytically, then that's how you have to do it. Okay, makes sense? So see here, I can do this. I can go x, right, times e to the power, right, negative x. See that here? We did this and the table is already set. So when we look at the table, you can see all the values are, displayed here, right?
So to set the table, we go to here, right? Table set F2.
Right. Okay.
Then we put 1 to 10, something like that.
Right. 1 to, I mean, it can keep on going forever, for as long as you want to see 10, 11, 12, but that asks you only for. Okay.
10, so
all right. Good. Now for this one, this thing where Rn, and first I have to write these guys and then I have to write the ratios. Okay, so let's do that separately. Okay, all right, so let's do that in a that might even be a little fun to do it that way. Okay, so see this here, first I have to write this sequence, right? A1, A2, etc., etc. See that here? And then after that I have to write the ratios. Okay, good. So here we are. So we want to write the first 10 terms, right? So let's get our calculator. So first thing we have to do in here is that we have to keep this in the radian mode. Okay, all right. Okay. Oh, actually, is tangent inverse? No, but again, just a moment. Yeah, right. Keeping it in radian mode will be good. Okay. So then, yeah, because when it's so when we go here, we'll put what? Sine of tangent inverse, which is this guy, right? Okay. And well, we will just say x, right? So we have entered this function. Make sense? Now we will set the table. So here is your table set. See that here? So say table set. Ask it to start at where? 1. Go in the steps of 1, and that's how we are doing, right? So that's what we will do, right? Okay, and then once you say table, see it gave you all the values, right? See this here? So it gave you the values like, from 1 to 7, and then got 1 to 7 for this, and then we have what?
So we cannot do more than 7.
Why? Yeah, right.
We have.
Yeah, they're all there, so you just have to get them from there, right? Okay, so we got these all. Okay, so here is for the first one, right? Okay, and for these guys we can do it the same way, right? Well, not for this one actually. This one will be slightly different, but this one can be done the same way for sure, right? Okay, makes sense? Okay,